probably talking to me. Okay. All right. So you guys, so let's actually go over the objectives and then we will check in with greatest common factor. I didn't notice that anybody wrote anywhere that we were having any troubles at this time, except for I know Saxon we're going to meet. Okay, so we're going to review the greatest common factor, like I said, and then we're going to look at some characteristics of polynomial functions. And for some of you guys, this will be really easy and you'll catch on really quick. But of the people that actually did that assignment, that's this week, I think it's the very first one, there was a little bit of struggling. Okay, and same info, pass on to you guys. So let's go actually look at this greatest common factor. So you guys all did a really good job on your notes, on your notepads, of listing an example. I love that. That was beautiful. So you guys write in here what you think the greatest common factor is of this quadratic. What is the greatest common factor? So you can tell me in words or you can write it in your notepads, whichever you want. Emma, did you put the 2 there for that? Okay, so yeah, you read it, you made it red. Okay, good. And so everybody else? Okay, so Brianna, you got an answer, good. David, what do you think? What do you think? And Saxon, what do you think? And Miriam. And Alicia. Alicia, you can put your name in a notepad, you know. You can have ownership of the notepad. Okay, you guys are taking a long time. 2 or 4, okay. Good guess, Saxon, thanks for telling me. So Saxon said 2 or 4. So Alicia, I see that you have written your name, that's marvelous. What do you guess? What's your guess? So right now I've got a guess of 2, I've got a guess of 4. Miriam said 4. Oh, hey Sam, I didn't notice you were here now. Alicia, what's your guess? Hola. Hola, Alicia. I'm getting a lot of 2s and 4s. And then Alicia said 2, but IDK it. Okay, so we got another 2. Okay, so this is really good we're doing this because see, this is the problem with this. So you guys, both 2 and 4 are factors, right? You can take 4 and you can divide it by 2. You can take 36 and divide it by 2, and you can take 56 and divide it by 2. So we know that 2 is in fact a factor. But is it the greatest factor? What do you guys think? Is it the biggest number that can go into 4, 36, and 56? Emma said no, 4 is. So Emma is on it, and Miriam already said 4, and Brianna already said 4. So David, what do you think? Do you think 4? Yes. Okay. So what we would want to do then is we would just want to double check, because if you only say 2 and you only pull out a 2, it's going to cause you lots of problems when you are factoring. So if we choose 4, we would just need to make sure that we could divide all of these terms by 4. Well, 4 goes into 4 1 and leaves x squared. 4 goes into 36 9 times and leaves x. And 4 goes into 56 14 times, I believe. So the only thing is, once you guys pull out the greatest common factor, it doesn't just disappear, poof, you know, like you erased it and it's gone. It's still there, right? Because this right here, what I have in parentheses, definitely does not equal what's up here. So you have to still keep track of that 4. So I put the 4 back on the end. When you guys are factoring this, and you guys are really good at factoring, I've seen you guys, you do awesome, and you break this apart into its, you know, factors. So I think it would break apart into 7x and 2x. When you break that apart, oftentimes you guys leave this 4 off because you're just working on this. And so you guys will do this, and you'll factor by grouping, and then, you know, you pull out your x, and you'll get x plus 7. You'll pull out your 2, and you'll get x plus 7, and you're so excited because you're like, oh, they're the same, and I'm doing it right, and then you pull out the x plus 7, and then what's left is x over here, and 2 over here, and you guys have done that, and you're so excited, and then you're done, and you leave it, and then the only problem is this poor little 4 right here, he feels so sad and alone, and he's crying because you left him out. So he has to come back onto the equation like that. So don't forget about the 4, what you pull out. Your GCF has to be back here. Because if you distribute x plus 7 times x plus 2, you will only get x squared plus 9x plus 14, and that is not equivalent to 4x squared plus 36x plus 56. So you guys make sure you're pulling out the greatest common factor, because many people, and it's not just you guys, it's like everybody, is only pulling out a 2, which is a factor, but it's not the greatest common factor. So anybody need to see another example? Another example, anybody? Nope. Okay, Brianna's giving me a nope. Brianna, you're so good. You always respond so fast. That's good. Everybody else good? Alicia, you are unresponsive right now. Sam said no too. All right, so David, I'm assuming Emma's good. David's good. Okay, good job, you guys. Good. All right, well, don't be afraid to tell me if you need another example afterwards or you need to go through something else. No problem. Okay, so basically, you guys, all I want to do on this webinar is to identify characteristics of polynomials. So really, it's just, this is kind of your first assignment this week, is you just take a polynomial and you need to identify the degree, what type of polynomial it is, whether it's positive or negative, number of turning points. I'm going to do a rough sketch because it's kind of hard for you guys to do a rough sketch over there. And then the end behavior is maybe something that's a little bit new, and it might be a little tricky for some of you guys, but hopefully this will kind of simplify it. So, does anyone know what degree I would give this first one? So if this was A, what degree would you give? How about, I'm going to go with Alicia, because you have nothing typed in your notepad. Alicia, what degree would this be? And some of you guys might be guessing because you didn't do this. Alicia! Alicia, are you there? Hello, Alicia. I am. Oh, you just, okay, see, that's good. At least you told me you don't know. Okay, so like Brianna is deferring here. Oh, nice, David. Good, you even answered B. Very nice. And C. Okay, so David is off and running, and Brianna's got the first one. So we're just going to go with you guys. So yeah, you always look at the highest degree. And in this case, the highest degree on this one is a 4, right? We have a degree of 2 here, but we always look at the highest degree when we decide what degree it is. So this is degree 4. And then if we go down here to, so see, it's really quite simple, you guys. Once I explain this to you, you'll be like, oh. And then when we look at type, well, we have linear functions, which have a degree of 1, right? Those are just like your y equals mx plus b. X just has a degree of 1 right here. We have quadratics, and you guys already know those are degree of 2. And then we have degree of 3, which is kind of what we've been working on a little bit, like this one. And those are cubics, like cube root, you know, cube. Well, it's not really like a cube, but a cube root. They call it cubic. I don't really know why. Actually, it always confuses me because I always think of cubic as 4, but cubic is 3. And then David actually got this one. If it is degree of 4, it's actually called a quartic. Quartic. How many quarts in a gallon? I think maybe 4. I don't know. Okay, and then David is going to continue on with you because you said it's positive. So the way you know it's positive is you always look at the coefficient of the highest degree variable. So I look at this 2, and that's positive instead of negative, so that's why I know it's positive. So see how easy it is to do 1 through 3? Very easy. Okay, so in order to do D, E, and F, what I'm going to do is I'm going to show you guys a graph of this function. So I'm going to go to this one real quick. And this is a graph, just look at this one on the left for a second here, of this quartic. Notice that a quartic, it's an even degree. It's 4, just like a quadratic, right? And if you think about a quadratic looks like a U. Both ends are going in the same direction, right? It's either positive and goes up, or it's negative and opens down. So those are your quadratic options. Well, this looks just like a quadratic, except for you've got this little extra turning point here in the middle. So that's one thing that you can think about. Anytime you have an even degree polynomial, the 2 ends are going to always go in the same direction, here and here. versus here in, or like here and here, versus this one on the right, which has an odd degree of 3, the ends go in different directions. And we'll talk about that one in a minute. But anyway, so these ends are going in the same direction. So you guys, how many turning points, if you look at this graph, how many turning points does it have? David, I think you might have done this assignment, or you already know. So you guys got it 3s? Awesome. 3. There is 3, exactly. I'm just going to circle them. There's one down here, right? There's one up here, and there's one down here. So there's 3 turning points on this one. Look at this one over here on the right. This is to degree 3, right? It's a cubic. How many turning points does this one have? Good, Emma, David, good. Nice. Okay, you guys you're all figuring out this has 2. Good job, you guys. So let me ask you a kind of a trick question. I'm going to go back to this. It's not really a trick question. So now you know turning points. What if I gave you a polynomial? I'm just going to make it up. We'll see how you guys do. What if I gave you a polynomial that was like 3x to the 6th, you know, plus 2x squared, I don't know, minus 20 or something like that. How many turning points is this polynomial going to have, do you guys think? How many? David, Brianna, good. You guys are guessing good. Alicia, you're not even going to guess. Oh, Sam, good. So everybody, Saxon, I know you're probably confused. This is week 5. Okay, so good, you guys. Everybody that, yeah, I know, Alicia, you are too. I know. You guys can catch up this week and this weekend. So, you what, Saxon? That's true. That's true. You could catch up. You could definitely catch up. And Alicia, you did very good. Okay, so you guys are exactly right. So it's 5 turning points. So if you guys figure this out, the number of turning points is always going to be the degree, which I'll call n, minus 1. So if you just subtract 1 from the highest degree, that's how many turning points you are going to have. So very good, very good. So our turning points on here, on this one, we said was 3. Okay, rough sketch. So I did a graph for you guys so that you could see it. But what you want to become good at is thinking, okay, well, it's even. So I know it's going to have to look kind of like this, but it has to have 3 turning points. So I need to like make an extra turning point in there. It's positive, so I know that it angles up instead of angling down like this one. And this is all I mean by a rough sketch, just doing something like that. So if we were to make a rough sketch of this, because it is a quartic, you know, degree of 4, and it's positive, I know that this is about how my graph's going to look. And once you have a rough sketch, you can do the very last thing, which is F, and F is your end behavior. So this is what confuses people sometimes, but it's really very simple, you guys. All you have to do is do this. Right, as x goes to positive infinity, and then write as x goes to negative infinity. So really what that's saying is, if I go back to my graph, as, here it comes, here's my graph, hopefully you guys see it. Okay, so as x goes out this way towards positive infinity, and as x goes out this way towards negative infinity, where are my ends going? Basically, where is the function moving? On this one, is this one going to positive or negative infinity, this end? Which one? So you guys just type either positive or negative. Good, Brianna, good. Yes, yes, very nice, David, good. Awesome job, you guys. This is going up here towards positive infinity. And notice that the other end is going in the same direction. It's also going up. This end is going up towards positive infinity as well. They're both going up to positive infinity. So the way you write that, it's really very simple. Like I was telling you guys, you always are going to start off no matter what with as x goes to positive infinity and as x goes to negative infinity. And then you're just going to write, and notice this is f of x. So you could write y goes towards, or you could write f of x is going towards positive infinity, and on the other end, as we go to negative, the function is still going to positive infinity. So the way you do end behavior, you always start with these x's, and then all you have to do is examine the ends and tell which way they're going. That's all you have to do. All you have to do. So you guys, we're going to conclude by looking at the very last one here. So we kind of went through it already, but why don't you guys do A, B, C, D. Just do A, B, C, D, how about? And then type in your notepads. I'm writing those out, A, B, C, D. Answer A through D in your notepads for this last one. How about that? So just type A, B, C, D, and fill that out. All right, good. You guys good? Alicia, Saxon, you guys could probably do it. Sam, what about you? Saxon's distracted. Oh no. Oh, distracting you. Alicia. You're so guilty, Saxon. So guilty. I know what it's like over there. He lies. I know how you guys are. Wait till I see you tomorrow. So much trouble. You're in so much trouble. Then bring the hammer down. I'm giving you double work. Look. I'm going to be there, Saxon. And I'm going to be really mad at you because you're not putting anything in your notepad. Whereas David and Brianna and Emma over here, and Miriam. Yes, good job, you guys. Sam, I'm not hearing from you. How do I find the number of turning points? Oh, Emma, that was a good question. Remember this n minus 1 up here? N stands for the degree, the highest degree. So take the highest degree and subtract 1. Subtract 1. All right, yeah, you guys, I think you guys are all just missing D. A, B, oh no, you're not. You guys all have, okay, so good, very good. All right, we're going to go forward because it looks like most of you guys are perfect. You guys are perfect, of course. So A is, well, you can see right there, degree of 3, right? Need a different color so it doesn't blend in. So A is degree of 3. It's a cubic function because it's to the 3rd power versus a quartic or a quadratic or a linear. C, positive or negative? What did you guys say? Negative. Very nice. Very nice. Okay, good. All right, and then D, number of turning points. Yay, you guys said 2, and that is exactly right because you take the 3, subtract 1 off, and that's how many turning points. Excellent. So, for the rough sketch and the end behavior, oops, that's not it. I know. It's thinking, it says weird stuff sometimes. Okay, all right, you guys, in your notepads for end behavior, so here's my rough sketch. Notice the ends are going in different directions. If you picture grabbing this bottom one and then somebody else grabbing the top one and you pull, it would almost look like a linear function. And a linear function has a degree of 1, which is odd. So anytime you have an odd function, the ends go in different directions. Okay, so in your notepads, if I go out here towards positive infinity, so as x goes to positive infinity, where is this end going? Okay, you guys, positive or negative? Nice, you guys are fast typers. Saxon, what did you say? Oh, okay, wait, Saxon, do you really have to go? You have 3 minutes. Okay, so Saxon, do me a favor and make sure you answer the discussion prompt because we're like done in 2 minutes, okay? It's in Schoology. It's in week 5. I can show you tomorrow too. Okay. Bye, Saxon. Bye. Okay, you guys. So now if we go the other way, so as x is now going towards negative infinity, where is this end going, you guys? Positive or negative? Positive or negative? Ooh, very nice. Yes. No, did you good? Yes, you're good. Brenna. All right. All right. I can see you guys are already getting there. So yes, it is going towards positive because it's going up, right? So anytime you go up on the y-axis, that's positive. Anytime you go down on the y-axis, that's negative. So hopefully this overview is helping you guys. But yeah, so if I was going to do my rough sketch, I just look at the fact that it's negative and it's a cubic, and I know that it's going to be like this, except for there's going to have to be two turning points, and this has none. So I would need to turn, and go down. And that's how I would do my rough sketch if I didn't actually graph it. I was graphing it just so you guys could see it, but you don't have to graph it. Okay, any questions, you guys? Any questions at all? Emma, no, you always have to read. 1 minute. We are actually done. See, we made it. It's good. Oh, okay. That's too bad, actually, Sam. I'm sorry. All right, you guys, well then here's your ticket out. So explain how knowing the characteristics of a polynomial can help you to make a rough sketch. Just go ahead and post your response in the discussion in Schoology, and that's your ticket out. And then don't forget to respond to other people. You guys are doing a good job. You guys are doing a good job in the class. And yes, Emma, definitely you can do it. You're always really good. You always do it later, so that's fine. So I hope you guys have a good day. And I'll talk to you all later unless anybody wants to stay. Bye, Emma. Guys are good? No? Miriam? David? Bye, Brianna. And Saxon is gone. Miriam is gone now. Bye, bye. All right. Very good, you guys.